This is 5 questions, and in this video what we're going to do is I'm going to go over 5 questions that you could perhaps see on the test. I recommend that you write this stuff down if you think you'll forget. Remember that you're allowed an index card for any kind of test that you take in here. Okay, let's look at the first one. This first one says solve for x and determine the angles, and I want you to notice that we have 2 lines that are parallel. This one and this one. You might want to consider extending some of these lines to make it look like something that's more familiar. So there you are. Remember that when it comes to parallel lines, you always have to consider interior, which is right there, and the exterior, which is right there. Also consider that for the transversal, that's this dividing line right here, this separates this thing into 2 halves. You have a left side and then you have the alternate side. Let's try to identify these 2 particular angles. You'll notice that both of these angles are on the same side as the transversal, namely this side. So that helps us with our identification. Another thing we need to consider is this. Are they interior angles? Or are they exterior angles? This is of interest to us because same-side interior angles and same-side exterior angles form a 180-degree angle. Well, there's your interior, and you see that only one angle is in the interior, not both. That's your exterior, and again, as you can see, there's only one angle in the exterior, not both. Therefore, it's neither of these. Therefore, it's neither of these. Also keep in mind, these are not alternate angles. Alternate meaning on alternate sides of the transversal. That leaves us with one possibility, and that's corresponding angles. It just so happens that corresponding angles are in fact equal to one another. You could in fact just measure one angle, and then if I were to move this and slide it over, you would see, hey, they're the same measurement. You could also figure this out knowing that this angle here and this angle here are vertical, and since they're vertical angles, this angle and this angle here, these form a Z shape, which makes them alternate interior angles, which again tells us they're equal. That's really what this thing is about. We need to determine whether or not those 2 angles are in fact equal to one another or not, and as you can see, they in fact are. So therefore, let's take the 5x and then set it equal to the other angle. That's 3 times the quantity x plus 10. And from here you're just using some algebra. Go ahead and take this 3 here and distribute to each term on the inside. And that gives us 3x plus 30. And then from there we can subtract 3x from both sides. We know to do that because both sides of the equation have x's, and we use 3x because this side here has more terms. So we want to kind of even that out, balance it out. We wouldn't minus the 5x because then there'd be nothing over here. Okay, so after these go away, we get 2x is equal to 30. Just go ahead and divide 2. And then we get our answer of 15. Okay, that takes care of this part. Now for this part. Determine the angles. Since we know what x is, what we can do now is we can take our x and we can replace it into x here and here. So in other words, 15 goes into those. And by the way, since remember, both angles are equal to each other, we really only need to replace into one of them. Let's go ahead and put into the 5x. Let's go ahead and take that 15 and plug it right in there. Do the multiplication, and we get that both angles are in fact 75 degrees. And that finishes the problem. For this particular problem, we got to determine the equation of a line, knowing only that we have just one point on it. The only other clue we have is that it's perpendicular to some other line. So essentially this is what you're being told. That's your given information. You have this line, and you have this point. And what you want to determine is the equation of some other line that is perpendicular somewhere along here, but also that it goes through that particular point. So that gives us one distinct answer. And because of that, and because of one very important relationship, and that is that perpendicular lines have slopes that are opposites and reciprocals, we need to determine the slope of this given line. Once we have the slope of that, then we can figure out the slope of the line we do want. And then along with that point, we can simply plug it in to get our answer. Okay, so let's determine that slope. That's our equation. What you want to do is you want to write this in slope-intercept form. Once it's solved for y, we can just simply grab the slope there for ourselves. So minus 2x from both sides because of the fact that you only want y over here, and we have this 2x which needs to be gone. And doing that, we wind up with 6y is equal to negative 2x plus 24. Let's divide out that 6 there because we only want the y. We don't want that 6 there. So doing that, and you divide 6 into everything, this is what you get. Keep in mind that 2 over 6 reduces to 1/3. 24 over 6 is 4. This is really unimportant. The only thing that's really important is that slope. Let's go back to the picture. The slope of the given line is negative 1/3, as you can see here. So what about this one? What's the slope of it going to be? Well, since they're opposites, that means that instead of negative, we're going to have positive. And since they're reciprocals, if you take 1 over 3 and you flip it over, we get 3. Okay, so that's a slope that we're going to use to finish off our problem. So this is what we've got. We got a slope of 3, and we have a point that's on that line. Now that we have that information, let's just take that and plug in that new slope and the point and back into this formula again. Remember that we're not caring about the fact that we had the 4. This is what we had at the end, remember? This is really unimportant. What really matters is this new slope that we have and the point that's definitely on the line. We have no guarantee that this point is on the line that we want, which is why we don't use it. So let's go ahead and plug that in. M is 3, and the point is an xy point, which means that the 9 goes in for x. So right here, that's why you're seeing 9. And since this is y, that's what you're seeing here. Simplify that, and let's go ahead and isolate b. And we do that by subtracting 27 from both sides. And that gives us negative 28. Okay, so let's finish this off. Now that we have the slope, now that we have the y-intercept, let's go ahead and place those back in for m and for b. That's our answer. Okay, that ends this first part. Now move on to part 2.